Hello everyone and welcome back to the channel. In today's applications, users expect real-time updates like instant messages, live scores, immediate notifications. But how do you get data from your server to your client in real time efficiently? While simple polling is inadequate, two primary strategies emerge: long polling and WebSockets. In system design reviews, knowing when to pick one server to another is crucial for building performant and scalable real-time features. Today we are diving into their differences, pros and cons. Okay, so first let's try to understand the challenge. And here I guess I will need to have my pen. Yeah, let's get my pen. Okay, so let's first remember the fundamental challenge. Standard HTTP operate on request-response model. So when we have a client, when we have a server, the client sends a request and the server sends back a response. The client asks and the server responds. The server cannot spontaneously push data to the client. If you want real-time updates, you can use what we call basic polling, which is a client will repeatedly send requests every few seconds. This is inefficient, creates a high latency and waste bandwidth. This highlights the problem that both long polling and WebSockets aim to solve, which is getting server initiates update to the client more efficiently. Okay, so let's try to understand long polling. First, in the concept, long polling, the client will make a regular HTTP requests, but the server intentionally holds that connections and we will make it open until either new data becomes available or predefined timeouts occur. Once data is sent or the timeout is reached, the server closes the connection and the client immediately opens a new one to start the process all over again. So again, when we have a client and we have a server, the client will send a request. The server will not respond immediately. It will hold it for let's say for 30 seconds or something like that. After that, it will send a response back to the client with the data if it's available or an empty request. So think of it like calling a customer service and being put on hold until an agent is free to give you an update. Again, how it works, the clients will send a GET requests, the server receives it. If no new data, server will wait for data or time out, like 30 seconds. If data arrives, it sends data and closes the connection. If the timeout has occurred, it sends an empty response and closes the response. The client then immediately makes a new request, and yeah, we will go this, so on and so forth. The pros and cons of this one. The pros is, first, we avoid empty requests. Unlike basic polling, it prevents the constant sending of requests when there is no new data. Number two, standard HTTP uses standard HTTP and HTTPS ports, making it generally compatible with older firewalls and proxies without special configuration. And number three, it's relatively simple. It can be somewhat simpler to implement for basic push notifications than a full WebSocket initiation. The cons of this one, it has too many cons. The first one, we have HTTP overhead. Still involves the overhead of HTTP headers and connection establishment, tear down for every event or for every requests. Also, we have a higher latency because the latency involved in waiting for current connection to close and a new one to be established before the next update. Number three, we have a problem with the server resources because servers have to keep many connections open for potentially long periods, consuming server resources, which can impact the scalability. Also, it's not bi-directional, to be honest. Like, while a server can push data, then a communication flow is still initiated by the client's requests. And yeah, so we'd say that it's better than polling, but it's not the case that we're looking for. Next, we have WebSockets. The WebSockets is pretty interesting because we have the client here, we have the server. It's a bidirectional communication. So once once the handshake is done, okay, the server can send the requests for the client without the client asks for them. So WebSockets provide a full duplex persistent bidirectional communication protocol over a single long-lived TCP connection. It's built on top of HTTP initially, but then it will upgrade the connection. This is like establishing a continuous phone call between the client and the server, whether both parties can speak and listen simultaneously at the same time. Let's try to understand how it works. For example, first, the client will make an HTTP handshake, because the client will send a regular HTTPS request, but with a special upgrade header. After that, we have a switch protocol. The server, if it supports WebSockets, responds with HTTP 101, which is switching protocol. This is switching protocol as code. After that, the persistent connection, like the underlying TCP connection, is then upgraded to a dedicated WebSocket connection, remaining open for a long duration. Lastly, we have a full duplex data flow. From this point on, data frames can flow instantly and simultaneously in both directions, client to server, servers to client, over this single connection, without the overhead of HTTP headers per message. The pros of this one, this has too many pros, to be honest. It's a true real time, because it enables instantaneous push of data from server to client. Also, we have lower latency, no connection re-establishment overhead once the persistent connections is set up. Also, we have minimal framing overhead after the initial handshake, saving bandwidth. So we reduced network overhead. Also, both client and server can send data whenever they need it, so it's truly bidirectional, and generally more resource efficient than long polling for high frequency updates, so it's more efficient. But what are the problems with that? First, we have a stateful connections. WebSockets maintain open stateful connection, which can complicate horizontal scaling. I guess often requires sticky sessions at the load balancer or specialized web token servers. Also, the complexity requires a more complex server-side implementation and managing persistent connections and potential disconnections. And also, it's overkill for simple needs, like not always for applications with very infrequent or non-critical updates. They don't need WebSockets. Okay, so how to discuss this in our views? And first, I would say how when to choose what. So in the system design interview, your choice depends on a specific requirements. For example, you choose long polling when first your real-time needs are simpler with infrequent updates. Two, you need broader compatibility with older network infrastructure, and this is a key. Number three, implementation simplicity is higher priority than absolute minimum latency. Number four, you are primarily pushing data from the server with less need for client-initiated real-time interactions. You choose WebSockets when you need a true real-time interactive applications like chat apps, online gaming, collaborative editing, or live dashboards. Also use it in low latency, high frequency, and bidirectional communication. Also, you use it when you are designing for larger scale systems where efficiency and performance outweigh the added architectural complexity of managing stateful connections. So when this topic comes up in a system design interview, clearly articulate the trade-offs, explain the overhead of long polling versus the statefulness complexity of WebSockets, justify your choice based on the application's specific latency, updates frequency, and interactivity requirements. For example, for a chat application, WebSockets are essential for their low latency bidirectional nature. For a simpler news ticker, long polling might be sufficient if complexity is a concern. So that's it for this video, and see you in the future.